Solving linear equations. All right, we have 4 simple steps that we can use in order to solve any linear equation. Step 1, simplify the algebraic expression on each side. That means that there are no parentheses, no like terms, and things like that. After that, we are collecting the variable terms on one side and the constant terms on the other side. I am going to do this with subtraction and addition. This is when you move things from one side of the equation to the other side. After that, I'm going to isolate the variable and solve. We do not want to know how many 2x is equal to or 3x. We want to know how much 1x is equal to. So in other words, in this case, I can use either multiplication or division. And the last part 4, is the best part in math. I can check my answer. How do I do this? Plug it into the original equation. All right, let's do some examples. We want to solve 7x is equal to 3 times x plus 8. So we have to do step 1 because the right side of my equation is not simplified. What I'm going to be doing is I am using my distributive property that says these parentheses are going to be opened up by distributing the 3. 3 times x is 3x. 3 times 8 is 24. Now both sides are completely simplified, and I now start with step 2, moving variable terms to one side. I am going to do this by taking the 3x on the right side, and I am subtracting 3x from both sides. What happens is on the right side, my x's are disappearing, and 7x minus 3x, that is 4x. This goes away. So I have now 4x is equal to 24. This is when I am now entering step 3. I am isolating my variable. I do not want to know how many 4x is equal to. I want to know how much is 1x. So I take the leading coefficient 4 and I just divide both sides by 4. 4 cancels out. X is equal to 24 divided by 4 is 6. And that means now that the solution set consists out of one number, the number 6. Now this right here I can check. I can take my number 6 and I can plug this back into my original equation. And I am always plugging things back in by replacing my variable first with the set of parentheses. So this equation right here now is the same as on the left, but my x is being replaced with the set of parentheses. Now I took my proposed answer and I plugged this in, and what I want to find out is whether the left side now is equal to the right side. I'm going to look. 7 times 6, last time I checked, that was 42. On the right side, the first thing that I'm going to have to do, what is 6 plus 8? That would be 14. And we quickly see 3 times 14, that would be 30, plus 12, that is also 42, which makes this a true statement, and that means that 6 was the answer. Let's do another example. Negative 7x plus 25 plus 3x is supposed to be equal to 16 minus 2x minus 3. I look at both sides and I realize that both sides can be simplified. There are no parentheses, but what we have are like terms. On the left side, I have a negative 7x and I have a positive 3x. These are two like terms that can combine. Negative 7 plus 3 will give us negative 4x. On the right side, I also have like terms. Here the like terms are the constants. I have 16 minus 3, and that will be 13. Now both sides are completely simplified, and I start moving things around from left to right, using addition or subtraction. I am first using the negative 2x, and I move negative 2x to the left side by adding 2x. I add 2x to both sides, and I'm careful here now with my signs. Negative 4x plus 2x, that is a negative 2x. On the right side, negative 2x plus 2x is cancelling out. And now I am taking my constant term, the positive 25. And how do I get positive 25 to the other side? By subtracting 25 from both sides. So I have a negative 2x is equal to 13 minus 25. Let's see, that would be negative 12. Do not use your calculator for calculations like this. All right, last step. I have to isolate my variable. I am not adding 2. I am dividing both sides by negative 2. And I get x is equal to negative 12 divided by negative 2 is a positive 6. And my solution set is the number 6. All right, one last example. We want to solve 4 times 2x plus 1 minus 29, which is supposed to be equal to 3 times 2x minus 5. Now, both sides are not simplified. I see parentheses. So the first thing that I'm going to be doing on the left side, 4 times 2x, 4 times positive 1. 4 times 2x, that will give us 8x. 4 times 1 is a positive 4. Minus 29. The negative 29 is not being multiplied by 4. It is not inside the parentheses. Right side, same thing. There's a set of parentheses, and I have to use my distributive property. 3 times 2x, that will give us 6x. 3 times a negative 5 is a negative 15. Now, I'm still not completely done with simplifying both sides, because on the left side, I see that I have 2 constant terms which can be combined. And I get 8x, positive 4 minus 29 will be a negative 25. All right, now I'm done with step 1. Now I start moving things around from left to right, again by subtracting or adding. Positive 6x moves to the left by subtracting 6x. 8x minus 6x, that will give us a positive 2x. All of this is equal to negative 15. Now the negative 25 moves to the right side by me adding 25. And I get the equation 2x is equal to negative 15 plus 25. That would be a positive 10. Now, strictly speaking, I could have done both of these steps at the same time. This step and this step could have been done at the same time, but it is safer to do them one at a time. Now, the last thing that I need to do is isolating my variable. So what I'm going to do, I'm going to divide both sides by 2, and x is equal to 5. That means that my solution set, the solution set consists out of one number, the number 5.